Welcome to Get Your FRQ On. This question is from 2023. It's question 6, and it is not calculator active. In the question stem, we are given an implicitly defined function, and that's it. In part A, we are asked to show that the derivative of our implicitly defined function, dy dx, is 2y over y squared minus 2x. Straightforward implicit differentiation problem. Start with your given function, 6xy equals 2 plus y cubed. This implies if we differentiate both sides, 6 times x dy dx plus y equals 3y squared dy dx. Eventually we're going to have to get the dy dx's together. So 6x dy dx plus 6y equals 3y squared dy dx. Simplifying this, 6x dy dx plus 6y equals 3y squared dy dx implies that 6x dy dx minus 3y squared dy dx equals negative 6y. Factoring out the dy dx, we get dy dx times 6x minus 3y squared equals negative 6y. And eventually dividing both sides by 6x minus 3y squared, we get dy dx equals 2y over y squared minus 2x. In part B, we are asked to find all points on the curve with a horizontal tangent line, or to show or explain why no such points exist. Now, for an implicitly defined function like this, especially since dy dx is a rational expression, we have to account for when the slope could be 0 versus when it might be undefined. Right? So the curve would have or could have a horizontal tangent line when the denominator of dy dx is 0, but the denominator is not. So we take our dy dx, 2y over y squared minus 2x, set it equal to 0. This would imply that our numerator is 0, which implies that y is equal to 0. But if y is equal to 0 and x were equal to 0, we would have 0 over 0. That would be undefined. So in order for this to actually be 0, y could be 0, but at the same time, it must be the case that x cannot be 0. X must be either a positive or negative number. All right? So now that we know y equals 0, but x is something else, we can take what we know and plug it back into our original implicitly defined function. So just replace all the y's with 0, and we get 6x times 0 equals 2 plus 0 cubed. On the left we get 0, on the right we get 2. That means we have 0 equals 2. Something you might notice about an equation like this is that it has no solutions. All right, since we got an equation with no solutions, there are no points on this curve where the tangent line is horizontal. In part C of this question, we have the flip side of that question: find all points with vertical tangents, or explain why those don't exist. All right, so in order to get a vertical tangent line here, we need our dy dx to be undefined. All right, so the curve may have a vertical tangent line when our denominator of dy dx equals 0, but the numerator does not. All right, so our denominator, y squared minus 2x, has to equal 0. This is going to imply that x is 1/2 y squared. There could be a lot of different places where this happens. Notice we're not limited or stuck with just a specific value of x or y. We happen to have a relation between x and y where this could happen. All right, and we can approach it the same way as we did in part B. We're going to take what we know and we're going to substitute it back into our original implicitly defined function. So I take x, replace it with 1/2 y squared, and I simplify. So 6 times 1/2 y squared y is going to get me 2 plus y cubed. That implies that 3y cubed is equal to 2 plus y cubed. If I subtract a y cubed from both sides, we get 2y cubed equals 2, which means y cubed is equal to 1, which means that y is equal to 1. Okay, so if y is equal to 1 and x is 1/2 y squared, then x is equal to 1/2. So on this curve, there should be a vertical tangent line at the point 1/2, 1. In part D, we consider the point on the curve 1/2 comma -2. And we're also given at this point dx dt is 2/3, and we are asked to find dy dt at this point. Now, this question seems a little bit implicit differentiation related ratesy, and it kind of is, although this really is about the chain rule. All right, remember, implicit differentiation and related rates questions are, at their core, questions about the chain rule, right? An implicitly defined function is an application of a chain rule when you differentiate it. So by the chain rule, we know that dy dt is going to equal dy dx times dx dt. Well, we just were told that dx dt is 2/3. And I have a formula for dy dx, which in theory I should be able to plug in 1/2 comma -2 into. All right, so if I evaluate dy dx at 1/2 comma -2, I can get a number that's actually -4/3. So at that point, dy dt should just be the product of those two things, -4/3 times 2/3, which is -8/9.